Okay, class, we're going to be doing set 2 problems of chapter 5, lesson 2. We're on page 189. And we have here problem number 4. What operation is the inverse of each of the following expressions? Let's go back to the definition. What is the inverse? It would be the operation that undoes the effect of the other. So we know that for addition, we would then subtract. For multiplication, we would divide. For subtraction, we would add, and for division, we would multiply. So these are the inverse operations to each of these. You don't have that in your problems, but it's good to understand this very well. You're going to be applying this constantly throughout, again, your math lives. Let's move on to number 5. In each of the following, what operation should be performed on the first expression to give the second? So here we have a series of expressions, 5x to give x plus 5 to give x minus 2 to give x, and you can see that we would have to perform the inverse variation. We're seeing a multiplication problem here, 5 times x. Okay, this is multiplication, so I would have to divide. What do I divide by? 5 if I want to give x. So your answer should be written in this form. Divide by 5. All right, so, excuse me. So there's your answer. I'm just going to do a few of these. X plus 5 to give x plus 5 to give x, I would subtract 5. Again, you can write this in words. Let's move down. X divided by 2. Okay, x divided by 2 to give x. Well, I'm dividing here, so I must multiply. And what I would do is multiply by 2. Or you can say 2 over 1, right? And you can see now that you have two factors that can cancel out, because 2 over 2 is equal to 1, so there you would have x. Let's see, further down, we're even asked to give 9, not actually x itself. Look at I and j. We're asked to give 9. We have two problems here. We have 9 minus x. Okay, so what would I do? Well, I would add x. All right, we're not dealing with the x variable. We're dealing with having this expression to give 9. So we subtract, or excuse me, add the x. In the second one, we have 9 over x. So we would then multiply by x, or x over 1, which would then lead to 9 as a result. Okay. Number 6, write a number or expression for each of the following. Okay, so this is a little bit different. Let me clear my board here and get my pen back. And we're being asked here now to write a number or expression for each of the following. Now, they ask the number that must be added to 3 to give 10. The number that must be added to 3 to give 10. So that would be 3 plus a number added to give 10. That would be 3 plus x is equal to 10. So the answer there, x would actually be equal to 7. Okay. And sort of just, again, one of those sneak previews, we're learning inverse functions, and we spoke already in our lesson about doing one thing to one side of an equation to the other. It's a sneak preview. How would I get this as 7? Well, I would have 3 plus x minus 3. That's going to cancel out our 3's here, wouldn't it? And then I would do the same to this side, 10 minus 3. So I subtracted 3 from each side. I could have taken our old simple mathematical structure of adding and subtracting. I could have just said minus 3 and minus 3. Some of you might find this to be a little easier. As long as I'm doing the same thing to each side of the equation, I'm okay. So 3 and positive 3, that would be 0. So I'm left with x, and 10 minus 3, well, that would be 7. So again, our answer is 7. Okay, so they're not really asking us to do that. I think a problem this simple is done just in our head. But in the future, we'll be adding that particular method and technique, and then you can see how it works on something as simple as 3 plus x is equal to 10. So a number that must be added to 3 to give x. Okay, now the number that must be added to 3 to give x. So now we have to pause and think. What exactly are they asking for? And before we can actually give that response, we're going to see that 3 is being added. And so we need to look at the inverse because we have to give x as an answer. Okay? And if we look at the inverse of adding 3 would be subtracting 3. So if I have x minus 3, okay, when I add 3, I'm going to get x, okay? That's basically what we're doing. It may sound a little confusing as to how they've worded it, but you want to think in terms of what the end result is, and what they're asking for us is to have x. That's the final result, to give x. So we know that x minus 3 plus 3, so we're adding 3. So this is the expression, this was the answer that they were looking for, x minus 3. What could we add to x minus 3 to give x? Well, it would be x, oh, excuse me. What could we add to positive 3 to yield x minus 3? Well, it would, I misspoke. What could we add to 3 to yield x? And that would be x minus 3. Okay, I think it's a little bit tricky how they worded that, but know that they wanted an answer of x, okay? And they started with 3. So how can I work this equation out that makes sense? Well, it would have to be x minus 3. And this is what they asked for originally. So let's move on. The number from which 7 must be subtracted to give 5. Okay, the number that must be added, the number from which must be subtracted to give 7. So what number would that be? Well, we would have to put, let's see, x minus 5, and it's giving 7, right? So, sorry, my 7's a little funny there. But what number would we subtract 5 from? Or as they say, what number must be, which 5 must be subtracted to give 7? And the answer for this would be 12. Okay? So they're looking for this particular answer. This is the expression, particularly that would show it, but the answer would be 12. And we can go on. You have quite a few of these. If you have any questions or any problems with them, I think they're going to challenge you to think in terms of building an expression and finding the problem. So continue on, and you have that represented in your problem number 12. Let's go to number 7. Write an expression for each of the following sets of operations. Well, multiply x by 2 and add 6 to the result. Well, if I multiply x by 2, that'll be 2x, and then I would add 6. Alright, so that would be the expression. Add 6 to x and multiply the result by 2. It's a little bit tricky. You gotta be careful. We're going to add 6 to x, but then we're going to multiply this result. I couldn't just multiply this by 2, because I would only multiply, if I just simply wrote it this way, I would only be multiplying according to the order of operations. I would multiply the 6, but they want to multiply the result. So we should be putting parentheses around this. Now you can write the 2 over here, which is fine, but typically we would put it to the left. Okay? So now x, we have 6 is being added to a number, or to x, and then that result is being multiplied by 2, and that's represented by the parentheses. Now we're told subtract 1 from x and, oops, sorry, number 3. Divide x by 5 and subtract 1 from the result. I'll divide x by 5 and subtract 1 from the result. Well, we're told to add 3 to x and subtract y from the result. Oh, I again, I'm sorry, I jumped again. That's letter D. Subtract 1 from x and divide the result by 5. So subtract 1 from x and divide the result by 5. So everything would be divided by 5. Okay. Add 3 to x and subtract y from the result. So add 3 to x, I have x plus 3, and add y. Now I could just put y. Being that we're adding, you can put parentheses here to represent this as a result, but it will work either way. Now it doesn't always work that way with subtraction, so be very careful. But in this case we could have written x plus 3 plus y. If you feel more comfortable, you use the parentheses. Now let's see, that would be E. Subtract y from x and add 3. So subtract y from x. So I'm subtracting y from x, not x from y. Alright, and again I could put my parentheses, and then I'm going to add 3. Okay. And again, you may say, well, I could go without the parentheses here. It's particularly when we're subtracting. And subtracting a couple of terms that are being added together. And we'll go further into this later on, but this is really the area of a lot of pitfalls in terms of when we're subtracting. What are we actually subtracting? But again, use your parentheses if you feel much more comfortable. Multiply x by 4 and divide the result by y. Multiply x by 4, 4x. Now you might tend to say, well, x times 4, is that what they said? Sure, but you can switch these multiplication terms. And then we're just going to go ahead and divide by y. Alright. And the last one, I probably didn't leave enough room here. Divide x by y and multiply the result by 4. Well, you could put x divided by y. Now to multiply this, you can just say, you can obviously put parentheses like this. You can actually just place it right up here, because when you're multiplying, you're creating the factor of 4 over 1, which is really 4x over y, so you can also express it 4x divided by y. Okay. Let's see, moving on to number 8. If you have done exercise 7 correctly, your answer should be the same as the expressions below. Oh, they're giving you all the answers now. What operation should be performed on each expression to give back x as the result? So now you're just going to undo some of this. You're going to work backwards. In the first one, say a, you have 2x. Your 2x plus 6, you would have to subtract 6 and then divide by 2. And again, I think you'll be able to figure these out. In number 9, you're asked to complete the tables by simply performing the mathematical operation that's given, whether it's adding, subtracting. You just go right down. You can see, for instance, -3. We're going to subtract 5. Well, that would give us -8. And then we're going to add 7, which would give us -1. So you just go ahead and fill in all these blanks. Simple math. Though you're going to be challenged with the negatives. And remember to consider even having a little scratch paper when you're told to subtract a negative, let's say, which means it's like adding a positive. So work with your scratch paper as well on the side. And lastly, let me just give myself a new board. Get my pen back. Now we're told here, number 10, the last lines of tables A and B in exercise 9 are the same because for any number x, we have, let's see, x minus 5, parentheses x minus 5, and parentheses plus 7 is equal to parentheses x plus 7 and parentheses minus 5. So we could see where the last lines on tables A and B. So if you're looking at tables A and B, you could see where they're relating these to each other. Now use the results of the rest of the tables to tell whether each of the following is true or false. So you're going to need to look at, let's say for letter A, we have x times 3 minus 2 is equal to x minus 2 times 3. Okay, they are playing on C and D. in that case, is it true or false? And could we say that x times 3 minus 2 is the same as x minus 2 times 3? And your results would have led you to understand that that's not necessarily true. Okay, we don't have the results here. We're not going through all these, but you're going to look at the results that you're getting in each of these tables to determine whether or not it's true, because they're trying to challenge you to think, does one equal the other? And so you're going to need to do that for your problems in between 15 and 16. 15 will be prepping up 16, number 16. So if you have any problems, again, I'm available. Send an email, and we'll certainly work them out in class if you have any questions.